Hello, everyone. Welcome to your chemistry classroom. I am Lawal Adetunji, your chemistry tutor. Welcome to your chemistry classroom. Welcome to your chemistry classroom. To our returning viewers. To our new viewers, welcome to the classroom. Please do well to press the subscribe button, turn on your notification button, press the like and share button, and put your comments in the comment box. As we have all know that we are still in the season of NECO 2025 and chemistry practical will soon be written. Likewise, we've released a lot of videos on chemistry practicals in this our channel and our second channel. Please do well to watch the videos we have released so far on chemistry practical. We have released video on quantitative analysis, which is the titration. Also, we have released video on qualitative analysis that we call SWOT analysis. This is another video on quantitative analysis, which will always come up on question 1. Here we have a question on the board. Question 1. Volumetric analysis or quantitative analysis. Let me write it here. I will put it here. Quantitative or quantitative analysis, or we call it volumetric analysis. We are saying the same thing. Alright, let's continue the business as we read the question. We have said that a solution A contains 0.10 mole per dm³ of triazonitrate 5 acid, that's our HNO3. And likewise, solution B contains 8 grams of a mixture of sodium triazocarbonate 4 and sodium triazonitrate 5. And the indicator there is methyl orange. We have the following procedure. The procedure you are seeing here is talking about the experiment. I have carried that one before this video, so that the video will not be too long. And at the end of the day, my total value that I got was 26.20 centimeter cube. That's what I got from the titration. So the question will present itself like this: celebrates and fill a burette with a solution A. You know, burette is 50 centimeter cube, so fill up. Using the pipette 20 or 25 centimeter cube, I used 25 centimeter cube for my own experiments, and I added 2 drops. Is there 2 to 3? I added 2 drops of methyl orange, and I got that 26.2. And it said titrate solution B with solution A until the color change from yellow to orange pink. If the color change from yellow to orange pink, you need to wait that endpoint, that color appears. That's what I did. And from there, now they said repeat the titration to obtain concordant results. I already did it. I did it twice. I got my result like this. Now I will soon go and prepare table, the way we are going to prepare our table in the examination. Now let's go to the equation. We are given the equation: sodium carbonate plus hydrogen triazonitrate 5 to give us sodium nitrate, water, and carbon dioxide. Truly, our solution is a mixture, but sodium nitrate is not visible in the equation. Now we have to say record the average volume of the acid used. When can I record such a thing until I know the volume of the acid? Remember, I told you my total value that I got was 26.2. Now let's start working on it. Now I have my final reading, red reading, initial reading on the board. Now I don't need rough title. I can put any values there. Let's say I just want to create a scene of 30.0 centimeter. Maybe I just put 5 here to complete it. Maybe I have my final for rough. I'm not using it. Now, yes, like I told you, I said when I carried out my experiment, I got my total value as 26.20. Now let me now show you, I did it twice. The first time I did it, I got 26.1, and the second time I did it, I got 26.3. So I'll find the average, and the average concluded and gave me 26.2. But let me write it the way I got it. I filled up my burette up to the end, that's 50. Now it showed that at that moment my initial was 00. And that moment when the thing was reading, I read it at 26 points. The first time I said I read it at 26.30. That's what made me to get 26.30 as my volume of acid for the first title. Because I know the capacity of the burette is 50. If I say I should continue using that particular remaining acid, and the sort of I may run out of acid. That's the reason why I fill it up again, so that it will take me back to my initial as 0 to be on the safer side. That's the reason why my initial for the second one also was 0. And when I did that one gave me 26.10. Now, I want to find the average. I think that will be the first question that they ask me to find the average, or recall the average volume of the acid. Now, I want to recall the average. How can I recall the average? I will say average titer in centimeter cube equals first titer plus second titer, all divided by 2. And what's my first? I got 26.30 plus 26.10. On addition with calculator, I got 52.40 over 2, and then I got 26.20 as my average titer value. Average titer value. Average titer value. I got it as 26.20. That is my VA. Now, that's how I settled question 1 and the table. Now, the questions underneath. The first question underneath says something. Calculate the number of moles of HNO3 used during the titration. You don't need to struggle. You have known my volume in centimeter cube. I will convert it to decimeter cube. That's number 1 thing. And number 2, we need to recall that the formula that said that total concentration and molarity is equals to the number of moles. Let me just say moles. Number of moles, or moles, any I call it, over volume. If you like, call it mole. Maybe I should use mole. Mole over volume. So what am I saying? That is, what I'm saying is this: my CA is equals to NA over VA. And remember, I want to find my NA here. My NA will now become CAVA. So what am I saying in short form? Remember, my VA is 26.20 centimeter cube. I will convert it to Convert it to DMQ to give me, there's a calculator. Using my calculator, 26.2 divided by 1000. This one is giving me 0.00026. But let me leave that in decimal. That is DMQ. That is my volume in DMQ. Now I can now go on, say my NA equals to, what is the CA of HNO3? We have been given, where is it? Question 0.1. 0.100 times 0.026. And at the end of the day, my number of mole of HNO3 during titration. During the titration, you can see the answer I got in titration, what I'm using. During the titration, I am having 0.0026. Because of accuracy sake, you can confirm with your calculator as well. Let me say this times so because of our yes, 0.0026 whatever. So that is my mole. That is, I have settled question B1. Now to settle question B2, the number of moles of sodium triazocarbonate 4 that reacted. Now we go back to the equation. They have mentioned the word reacted. So we go back to the equation to work with their relationship. Here we can see 1 mole of sodium carbonate is one reacting with 2 moles of hydrogen triazonitrate 5, which means, let me rub my butt to have it better. I think I can take away this table. I can take away this table right now because I want to make this environment my solution brand. So let me take away the table. I have used the table. Now, here you can see that we say 1 mole of Na2CO3 is equals to 2 moles of HNO3. Now, How many of these will not satisfy that one? That is 0. Okay, no, under HNO3. So Y will equals to 0.0026 mole of HNO3, which means that Y equals 0.0026 divided by 2. Then my calculator satisfy that one. That is this answer. Okay, that is 0.0026 divided by 2. I have 0.0013 mole of Na2CO3. And we satisfy the question 2. Right, that's how I'm going to finish it. The 5 questions. We have settled 2. We are going to the third one. Very simple question they have asked us so far. But now the third question says we should find the molar concentration of sodium carbonate in solution B. We are still coming back to fall into this type of formula again. Y, mole, and likewise, what again? We are saying mole. What again do we need? We want to find the molar concentration, we need mole, and my volume of base, which is the volume of pipette. Normally, in my exam, I need to state what I'm using. I'm using volume of pipette as 25.0. Please take notice, must be there. You must put all those things there, and likewise, an indicator. My volume of pipettes. The volume of pipette I'm using is 25.0 centimeter cube. Now, go to number 3 to find. Number 3. To find the molar concentration. To find the molar concentration of B. Since I, you know that molar conc is equals to mole or number of mole of soluble volume. So in that sense now, the mole I got here now, the mole I got here is 0.0. Are we there? 0.0013 over my volume of acid. Now, I'm a volume of base. Volume of base. But what's my volume of base? 25. Which I must convert. 25, which I must convert to decimeter cube. If I want to convert to decimeter cube, that is 25 divided by 1000. If I flip it over, the 1000 will come up. So I'm having something like this. So that at the end of the day, I'm going to have, get my calculator, get that one because of accuracy's sake. So I'm having 1.3 divided by 25. 1.3 divided by 25, and what will be the answer? My calculator got 0.052 mole per dm cube. That's how we satisfy question number 3. Can you see the way I'm making it? Gradually remain 2 questions. So let me clear up my board so that we can satisfy the remaining questions. NECO 2025 continues. As I want to solve question number 4, please do well to press the subscribe button, turn on the notification button, and try to watch all our videos in our playlist. Now to get my mass concentration. I've rolled up my board. Now to get the mass of concentration. Remember, there is a formula. Well, what's that formula? Can you still remember? The formula that relates molar mass and mass concentration together. Number 4. Since molar concentration is equal to mass concentration over molar mass. The next thing we now ask ourselves is what's the molar mass of sodium carbonate? Let's calculate that. The molar mass of sodium carbonate. That is 23 times 2 plus carbon, which is 12, plus oxygen, 3, that is 16 times 3. When we put everything together, we are going to get 106 gram per mole. So in that sense now, molar concentration, we just got it right now, we got 0. Are we there? 0.052 equals mass concentration we don't know. That is, let's call it Y over 106. So when you cross multiply, let me do that. My calculator is here. 0.052 times 106. I'm having 5.151 grams per what? Gram per what? Per dm cube. That is my mass concentration of Na2CO3 is 5.51 gram per dm cube. Now you are satisfied. Question number 4. Can I see it properly? Yes. Now to solve question 5, please do well to press the subscribe button, turn on the notification button, like and share, and put your comments, your observation in the comment box as we are rounding off the question, the percentage by mass of sodium carbonate. So what am I saying? When we talk about percentage by mass of Na2CO3, that is, it means the mass of Na2CO3 over total times what do you call it, 100. So I have mass of Na2CO3 over total mass times 100. When I total mass, that is the mass of the mixture, both sodium carbonate and sodium trinitrate. So what am I having now? 5.51 over what's my total mass that will give to us in the question? No, we are not using that at all. That 8 gram. That's the total mass. Over 8 times 100. So my calculator should judge that as we are closing this video. So I have final answer here as 68.9. My answer, 68.9%. And that is how we finish all the questions that I and you were expecting to come out in this NECO 2025 chemistry practical. Questions have been given, solutions have been supplied and provided, and success is ours. Thank you so much for being there. Please do well to watch all our videos. Check our playlists. A lot of videos are there for you to watch. We have video on qualitative analysis. Please watch. We still have the videos on this titration quantitative analysis. Please do watch. We have videos on physics practical, both the mechanism, the lights, and the electricity. Please do watch and put your comment in the comment box. Do well to subscribe. I will be waiting for you in the next video. Bye.